For the purposes of the National Electrical Code, specifically sections 250.104a, 250.104b, and 250.50, sprinkler piping is classified as other piping. To understand the significance of this classification, let's delve into the details of these code sections and their implications for grounding and bonding. Section 250.104 addresses the bonding of metal water piping systems and other metal piping that may become energized. This section mandates that metal water piping systems that are likely to become energized be bonded to the grounding electrode system. The purpose of this bonding is to provide a low impedance path for fault current, facilitating the operation of overcurrent protective devices and minimizing the risk of electric shock. The key element here is the phrase likely to become energized. Water piping systems are often in contact with grounded surfaces and may be subject to stray currents or faults in electrical equipment. Therefore, they require bonding to ensure electrical safety. Now, let's consider section 250.104b, which deals with the bonding of other metal piping systems. This section applies to metal piping systems that are not water piping but may still be subject to energization. Examples of such piping systems include gas piping, compressed air piping, and, importantly, sprinkler piping. Unlike water piping, these other piping systems are not as likely to become energized due to their inherent characteristics and typical installation practices. However, the code recognizes that under certain circumstances, these systems could still be subject to electrical faults or stray currents. Therefore, section 250.104b requires these other piping systems to be bonded to the grounding electrode system if they are likely to become energized. The decision of whether or not to bond other piping systems like sprinkler piping is based on a risk assessment. Factors to consider include the proximity of the piping to electrical equipment, the potential for contact with grounded surfaces, and the presence of any known sources of stray current. If the risk of energization is deemed significant, bonding is required. Section 250.50 focuses on the grounding electrode system itself. This section outlines the requirements for establishing an effective grounding electrode system, which serves as the reference point for all grounding and bonding activities. The grounding electrode system must consist of one or more grounding electrodes, such as metal underground water pipe, a concrete encased electrode, a ground ring, or ground rods. It also requires that all available electrodes be bonded together to form a single, integrated grounding system. The inclusion of sprinkler piping under the umbrella of other piping has implications for the overall grounding and bonding strategy for a building. Because sprinkler piping isn't inherently treated as requiring mandatory bonding like metal water piping systems, its bonding requirements are contingent upon a risk assessment. If the risk of the sprinkler piping becoming energized is determined to be low, bonding may not be necessary. However, it is crucial to thoroughly evaluate the specific conditions of each installation to make an informed decision. Several factors contribute to the determination of whether sprinkler piping should be bonded. Firstly, the type of sprinkler system is a key consideration. Wet pipe systems, which are constantly filled with water, may present a greater risk of energization than dry pipe systems, which are only filled with water during a fire event. Secondly, the proximity of the sprinkler piping to electrical equipment is an important factor. If the piping runs close to electrical panels, conduits, or other sources of electricity, the risk of a fault increases. Thirdly, the building's construction and grounding system play a role. If the building has a robust grounding system with multiple grounding electrodes, the overall risk of energization may be lower. Fourthly, the local electrical codes and regulations must be followed. Some jurisdictions may have specific requirements for bonding sprinkler piping, regardless of the risk assessment. In cases where bonding of sprinkler piping is deemed necessary, the bonding conductor must be sized appropriately based on the requirements of the National Electrical Code. The bonding conductor must be connected to the sprinkler piping using a listed connector that is suitable for the application. The connection must be made in a manner that ensures a reliable electrical connection. It's important to ensure that the bonding conductor is protected from physical damage. The National Electrical Code provides specific guidance on the methods for protecting bonding conductors, such as running them in conduit or using approved supports. The selection of appropriate bonding methods should take into account the specific environmental conditions of the installation. For example, in corrosive environments, corrosion-resistant connectors and conductors should be used. It's crucial to maintain documentation of all grounding and bonding activities, including the risk assessment, bonding conductor sizes, and connection methods. This documentation can be valuable for future maintenance and inspection. Regular inspections of the grounding and bonding system should be conducted to ensure its continued effectiveness. Inspections should include visual examination of the bonding conductors and connections, as well as testing of the grounding electrode system impedance. The determination of where the sprinkler piping should be bonded requires careful consideration of the applicable codes and standards, as well as a thorough understanding of the specific conditions of the installation. By following the guidance provided in the National Electrical Code and other relevant standards, it is possible to ensure the safety and reliability of electrical systems in buildings with sprinkler systems. The classification of sprinkler piping as other piping highlights the importance of performing a thorough risk assessment to determine the appropriate grounding and bonding requirements. This approach ensures that electrical safety is maintained while avoiding unnecessary bonding where it is not needed. Remember to consult with a qualified electrical engineer or inspector to ensure that all grounding and bonding requirements are met. Electrical codes can be complex, and it's crucial to have expert guidance to ensure compliance and safety. Now, let's explore the differences between water piping and other piping in more detail, focusing on the factors that influence the classification and bonding requirements. Water piping systems, typically composed of metallic pipes like copper or steel, are used to distribute potable water throughout a building. These systems are inherently grounded through their connection to the water source and their extensive contact with the earth. This grounding makes water piping systems more susceptible to becoming energized due to electrical faults or stray currents. For instance, a fault in an electrical appliance or wiring system could introduce current into the water piping system, potentially creating a shock hazard for anyone who comes into contact with the pipes. To mitigate this risk, the National Electrical Code mandates that metal water piping systems be bonded to the grounding electrode system. This bonding provides a lower impedance path for fault current, allowing it to flow back to the source and trip the overcurrent protective device, such as a circuit breaker or fuse. The bonding connection must be made at the point where the water service enters the building, and additional bonding may be required at other locations throughout the system to ensure its effectiveness. In contrast, other piping systems, such as sprinkler piping, gas piping, and compressed air piping, are not as inherently grounded as water piping systems. These systems may be made of various materials, including metal, plastic, or a combination of both. They typically have less contact with the earth and are less likely to be directly connected to the water source. As a result, other piping systems are generally considered to be at a lower risk of becoming energized compared to water piping systems. However, the National Electrical Code recognizes that these systems can still become energized under certain circumstances, such as through contact with electrical equipment or through stray currents. Therefore, the code requires a risk assessment to be performed to determine whether bonding is necessary. If the risk of energization is deemed significant, the other piping system must be bonded to the grounding electrode system in accordance with the code requirements. The specific bonding requirements for other piping systems may vary depending on the type of piping, the materials used, and the specific conditions of the installation. For example, gas piping systems may have additional bonding requirements to prevent the buildup of static electricity, which could ignite flammable gases. Sprinkler piping systems, as discussed earlier, may require bonding if they are located near electrical equipment or if they are likely to come into contact with grounded surfaces. The risk assessment for other piping systems should take into account several factors, including the proximity of the piping to electrical equipment, the potential for contact with grounded surfaces, the presence of any known sources of stray current, and the type of materials used in the piping system. Based on this assessment, a determination can be made as to whether bonding is necessary to ensure electrical safety. It's important to note that the National Electrical Code provides specific guidance on the methods for bonding both water piping systems and other piping systems. These methods include using approved bonding connectors, sizing the bonding conductors appropriately, and protecting the bonding conductors from physical damage. The code also specifies the locations where bonding connections should be made, as well as the requirements for maintaining the integrity of the bonding system over time. In addition to the National Electrical Code, other relevant standards and regulations may also apply to the grounding and bonding of piping systems. These standards may be developed by organizations such as the National Fire Protection Association or by local regulatory authorities. It's essential to consult with these standards and regulations to ensure compliance with all applicable requirements. When in doubt, it's always best to consult with a qualified electrical engineer or inspector to obtain expert guidance on the grounding and bonding of piping systems. These professionals can provide valuable insights and recommendations based on their knowledge and experience. By following the guidelines provided in the National Electrical Code and other relevant standards, it's possible to ensure the safety and reliability of electrical systems and buildings with both water piping systems and other piping systems. A thorough understanding of the differences between these systems, as well as the factors that influence their bonding requirements, is essential for achieving this goal. It's also important to remember that electrical codes are constantly evolving, so it's crucial to stay up to date on the latest requirements and best practices. Regular training and education can help ensure that electrical professionals have the knowledge and skills necessary to properly ground and bond piping systems in accordance with the current standards. By prioritizing electrical safety and adhering to the applicable codes and regulations, we can create safer and more reliable buildings for everyone. In conclusion, sprinkler piping falls under the category of other piping according to the National Electrical Code. This classification necessitates a thorough risk assessment to determine if bonding is required to ensure electrical safety. This assessment considers factors like proximity to electrical equipment, potential for contact with grounded surfaces, and local regulations. Proper bonding, when deemed necessary, involves using appropriate connectors, correctly sized conductors, and protection from physical damage. Regular inspections and adherence to the latest electrical codes are crucial for maintaining the integrity of the grounding system. Consulting with qualified electrical professionals is always recommended for compliance and safety.